In today's video, we're going to continue to solve radical equations. We are going to, in this case, example 4, we're going to solve a radical equation that has another variable x that is not in the radical. So the first thing we want to do, just like any radical equation, is isolate the radical by itself on the one side. So what we would do here is subtract x. Sorry, I meant to say subtract 5. We're moving the 5 over to the right. So subtract 5 and we'll have x minus 5. Please don't subtract them. They're not like terms. Then after that, we want to get rid of the radical. So we are going to square both sides. Now we have to be careful on the right. This is two terms, so we have to put parentheses squared. On the left, it's just going to cancel out the radical and the exponent. On the right, we got a bit of work to do, though. Unfortunately, we have a binomial squared, so that means we have to write it twice, and then we're going to have to FOIL and combine like terms. So I'm going to FOIL this right now. First, outer, inside, and last. Now, many people get stuck at this point, but we have to look at what kind of equation it is. It has an exponent of 2 in it. That means it's called a quadratic equation. And a quadratic equation, we want to set it equal to 0, and then we can either factor or use the quadratic formula. So first, before I do that, let's combine like terms. I should combine these guys to make minus 10x. Now I want to I'll make the left, since the x squared's on the right side of the equal sign, I'll make the left side equal to 0. So I'm going to subtract x, subtract 7. So then I look from there, and again, it's a quadratic, so we do have it set equal to 0. So you can either factor here or use the quadratic formula. I try to think, do I have two numbers that multiply to 18 and add up to 11? Yes, I do, 9 and 2, so that means I can factor this. My signs, when the C is a plus, but that means the signs are the same. They're both minus. So we'll put minus, minus. And as I said, two factors that multiply to 18 and add up to 11 are 9 and 2. So those are my factors. Now I'm going to go ahead and I'm going to get my answers. So remember, you set up the two little equations, set each factor equal to 0, and then solve each of them. So the first one, we would say x is 9 and x is 2. However, we do have to check for extraneous solutions. Maybe those aren't the actual answers. So let's check 9 first. I'm going to remember, you're plugging them into the original equation. And 9 works out to be okay, so 9 is in fact a real solution. And now I'm going to check to see if 2 works out. And 2 does not work out. We would say that 2 is an extraneous solution. So as we see, this is why it's important to check. Things don't always work out. Okay, let's show you another one. That, including the check, took about 5 minutes. So let's try another one here. As always, we want the radical isolated on the one side, which it is. So I'm going to get rid of the radical by squaring both sides. So on the left, just get rid of the radical. On the right, the same as the previous problem, we're going to have to write this out twice and then FOIL and combine like terms. First, outer, inner, and last. And then combine like terms. Add the 7x plus 7x to make plus 14x. Bring these down. And again, I have a quadratic, so I want to set this equal to 0. So I'll set my left equal to 0. Add 2x to both sides. Subtract 1 from both sides. So I have my 0. So then I either factor or use the quadratic formula. Can I factor here? I'm thinking in my head, are there two numbers that multiply to get 48 and add up to get 16? Yes, 12 and 4. So x plus 12 and x plus 4. And then we would set each factor equal to 0 and then solve them. So we have answers of -12 and -4. We think we do. Let's check them now. So I'll start checking -12. -2 times -12 is 24. That'll be a square root of 25, which is 5. And the right side, -12 plus 7, gets -5. That does not, whoop, I put a check. That does not equal. So -12, cross it out. That's an extraneous solution. Now let me check the -4. -2 times -4 is 8, and then 8, so then 8 plus 1 is square root of 9, which is 3. And then on the right side, x plus 7, -4 plus 7 is 3. So the -4 does work out. We do have one answer here. So not too bad. What we've been doing the last two problems is, when you have a radical and you end up with a binomial on the other side, like the x plus 7, you're going to have, when you square both sides, you're just going to have to FOIL, combine like terms, and then and then set it equal to 0, and then either factor or use the quadratic formula to solve. And of course, check your solutions after you're done. All right, so now, next up, what if there are two radicals? If there are two radicals, we want to isolate one radical on one side and then square both sides. Then, if you end up still having one radical, you'll have to isolate that radical and repeat your steps. So, this is where it's going to be tough, but you guys can do this. All right, so let's isolate one radical. Do not square until you isolate a radical. So we're going to subtract to move that second radical to the right of the equal sign. Okay, now it's going to get tough. Now we're going to square both sides. However, we do have a binomial on the right, and this is where it gets really challenging. Yeah, the left is fine. Left side, you just get rid of the radical, but the right side, we are going to have to write this out twice, and then FOIL and combine like terms. All right. So listen closely here. So first, 4 times 4, 16. Now the outside's 4 times negative square root of x plus 5. That will be minus 4 times the square root of x plus 5. Then the inside is negative times 4, negative radical x plus 5 times 4. I said that totally wrong. Meant to say negative square root of x plus 5 times 4 is just the same thing as the term before it. And then last times last is going to be negative times negative will be a positive. And then the square root of x plus 5 times the square root of x plus 5. When you're multiplying the radicals and they're the same thing, you just get rid of the radical and you just carry over what was in it, the x plus 5. Okay, so where do we go from here? Let's combine like terms. Actually, 16 plus 5. 16 plus 5 gets 21. And then bring down the plus x. And then the two radicals have negative 4's in front of them. So negative 4 minus 4 is negative 8 times the square root of x plus 5. Now what? Now what do? We still have a radical in this problem. Let's do what we've been doing with these radical equations. Let's get the radical by itself. You always want to be working on getting a radical by itself. So I'm going to move this term to the left, this term to the left. So I'm going to subtract 21 from both sides. And I'm going to subtract x from both sides. Actually, it'll cancel here as well. That's always a good thing when things cancel. The radical's not isolated yet. We have a negative 8 in front. We want to divide both sides by negative 8. So now we have a radical by itself. So let's get rid of it, the radical, by squaring both sides. So on the left side is 9, 3 squared. And the right side, you can just drop the radical and have x plus 5. And then you can, well, that's a nice easy one to solve. Subtract 5 to get 4. 4 is x. So we just got one answer here, but we are going to check out to see if it is, in fact, going to check out. Check 4. Is it going to be a real solution or an extraneous solution? So square root of x minus 3, so that'll be square root of 4 minus 3 is 1, plus, and then the square root of x plus 5. So that's square root of 4 plus 5 is 9, equals 4. Square root of 1 is 1. Square root of 9 is 3. And of course, 1 plus 3 is 4. So we do have a good answer. We have x plus 4. So yes, what we just did was pretty challenging. Feel free to go back. Do I expect everybody to, get this down 100% right away? Nope. So at any point, if you need to cycle back in, what I always suggest is, have your packet on the side or your notebook on the side. And when you hit problems, in your homework to kind of do them side by side with each other. You know, pause the video frequently and then kind of mimic the steps as I'm doing them with an assignment problem. Lesson's not done yet, though. I am going to hit up one more problem, example 7. It's very similar to number 6 with 2 radicals. So let's get a radical by itself. So I'm going to add square root of x to move it to the right. So it'll be square root of x plus 1. You know, it starts on the left as a negative square root of x, so move it to the right as a positive. Don't combine them. Don't add them because they're not like terms. Okay, so now that one radical is isolated, I can get rid of its radical by squaring both sides. I am going to have a lot of work to do on the right, though. On the left, very easy. Just drop the radical. The right side, write it out twice, and we're going to FOIL it. So first times first, so that's square root of x times square root of x is x. Remember, when a square root multiplies by itself, the identical self, it just drops the radical. Then square root of x times 1 is 1 times the square root of x. And then inside is the same thing, plus 1 square root of x. And then last times last, 1 times 1 is 1. Now, combine like terms. X drops down. Square root of x times the square root of x. Again, imagine they have 1s in front of them, so it would be 2. They add up to 2 times the square root of x. Now, what would I do from here after I combine like terms? Well, let's work on getting that radical by itself on the right, and then we can square both sides to get rid of it. So let's subtract x to cancel this, and subtract 1. So on the right side, just dropping down 2 times the square root of x. On the left side, these add up to 0. 3 minus 1 is 2. And then, still don't square yet. We still have to isolate the radical, divide both sides by 2. And that would be 1 equals the square root of x. Now that the radical is by itself, we can get rid of it and square both sides. So x equals 1 squared is 1. Now let's check our solution to see if 1 is an actual solution. So the square root of 1 plus 3 is 4, minus square root of 1 equals 1. Square root of 4 is 2, minus square root of 1 is 1, and 2 minus 1 is 1, so 1 is our answer. So make sure that when you guys are doing this homework, your homework assignment, I see those checks on the side as well. All right, guys, that was at the end of the lesson.